So we want to find out how much energy it's going to take to heat up 245 liters, and assuming that each liter equals 1 kilogram, 245 kilograms of water, so that's our mass M, from a final or an initial temperature T sub I of 10 degrees to a final temperature of 45 degrees. The specific heat of water is 4,186 joules per kilogram times degrees Celsius. And then we want to know how long it would take if the heater output is 9,500 watts. So power here is 9,500 watts. Okay. So for part A, the amount of heat energy required is given by equation 14-2. Okay. So according to equation 14-2, Q, the energy, is equal to the mass times the specific heat constant C times the change in temperature delta T. Well, this is going to be equal to the mass, which we know, times C, which we know, and delta T is T final, like a parenthesis there, T final minus T initial. So plugging those values into this expression, we find that this is equal to 3.589 times 10 to the 7 joules for our energy. And box that in as a solution. That's the energy required to heat up the water by that amount. Now for part B, it wants us to know the time it's going to take if the power output is 9,500 watts. So energy, Q, is equal to, well, let's use the equation for the power. It's equal to the energy, Q, divided by the time, T. So solving for T, we have T is equal to Q, which we just calculated, over P, which is 9,500 watts. Plugging those values into this expression, we find that this is equal to 3,778 seconds. Well, that's about 63 minutes or about 1 hour, but we're just going to leave it in second form.